Hello, welcome back to my channel. Today I want us to look at the JAMB 2025 question. Of course, this is for day 2. The other time we treated the day 1. If you have not watched the day 1, please, the link is down below. Now, before we proceed, of course, as usual, if you have not subscribed to my channel, do me this favor, hit the subscribe button, hit the like button, and then please share this video with your friends. If you have a WhatsApp group where you have JAMB students, please share this video in that platform so that they can have access to this, because as days go by, JAMB questions continue to be tough. Day 1 is easier than day 2. Who knows what day 3 will give us? Now we start. The first question says, the majority charge carriers in P-type semiconductors are. The majority charge carriers in P-type semiconductors are. We have the neutrons, not there, not among the options. We have the free electrons. We can consider that. We have the C, the holes, D, the proton. Now it is between the holes and the proton. Now because they say P-type, for P-type semiconductor, the charge carriers are always the holes, and of course the holes are the positive charges. While you want to hear N-type, the charge carriers in N-type semiconductors are the free electrons. But for this, because this question is on P-type, the correct answer option there is the hole. So the hole is the charge, the majority charge carriers. They can as well, please, this question, remember, they cannot give it to you exactly. They can clone it. One can always ask, what is the minority carrier, maybe in P-type or in N-type? If they say minority carriers in P-type, minority charge carriers in P-type are the free electrons, while the majority charge carriers are the holes. If they turn it the other way around and ask you the minority charge carriers in N-type, the minority charge carriers in N-type, they are the holes, while the majority charge carriers are the free electrons for N-type. Now we move to the next question. I am rounding it up so that this video can accommodate as many questions as possible. Now we have the second question. The second question says, the wave property which can be used to differentiate between a sound wave and a light wave is dash. The wave property which can be used to differentiate between a sound wave and a light wave are, of course, the options there are, I will start from the list, the D option. We have the interference, we have the refraction, we have the reflection, and we have the polarization. Now, the difference between sound and light is as a result of those features. 4 of them are the features of waves. But light and sound, they are not the same. Of course, light can undergo polarization. Light can undergo reflection, it can undergo refraction, it can undergo diffraction and interference. The same thing with sound. Sound can undergo interference, sound can undergo sound can undergo interference, it can undergo diffraction, it can undergo reflection, it can undergo refraction. But sound cannot undergo polarization. Because of that, the only thing that you can distinguish between light and sound is the polarization. So polarization is the correct answer option. Now we take the next one. We have this question on the board, and this question says 20 grams of liquid evaporates at its boiling point when a coil of resistance 4 ohms in which a current of 0.2 ampere flows for 1 minute. Determine the specific latent heat of vaporization of the liquid. Specific latent heat of vaporization of the liquid. Now the answer must be among those options there. Now we have, and of course from here, mass. The mass there is 20 grams. Now you do the conversion immediately because this one is in kg, which will give us 0.02 kg. Okay. The resistance there is 4 ohms. Current flowing in the circuit is 0.2 ampere. Now the time there is 1 minute, and of course you convert it to seconds, which will give us 1 minute times 60 seconds will give us 60 seconds. Now determine the specific latent heat of vaporization, and of course specific latent heat of vaporization is L. Now we recall that yes, Q is equal to ml or mlv, however you want to put it, ml or ml subscript v. And as well, the same Q is equal to I squared RT. You can also say Q is equal to IV squared, IVT. And of course, if you start going to IVT, it will take us our Israelite journey. So because Q is equal to this, Q is this, therefore we can equate this to MLV is equal to I squared RT. Now substitute straight. M is 0.02 multiplied by LV is equal to I squared 0.2 squared times R. R is 4 multiplied by T. T is equal to 1 times 60, which is 60, which will now give us 0.02 LV is equal to 0.04 multiplied by 4 multiplied by 60. Now 0.02 LV is equal to, now 0.04 multiplied by 4 multiplied by 60 will give us 9.6. Therefore, LV will give us 9.6 divided by 0.02, and that will give us 480 joules per kg, and that is the correct answer option. So we'll take another one immediately. This question says, calculate the peak value of the mains supply of RMS value, 220 volts. Very simple, straight question. Now we have, and of course the only thing given to us is VRMS. VRMS is given to be 220 volts. Now the peak value is not given. Now how do we get the peak value? Of course we have the formula that says V RMS is equal to V naught all over square root of 2. Now if you substitute straight, we now have that V RMS is given to us as 220 volts, which is equal to V naught, what we're looking for, all over square root of 2. Now if you make V naught the subject, we now have 220 multiplied by the square root of 2, which will give us 220 multiplied by square root of 2 is around 1.414. Now if you multiply it by 220, we have that V naught is 311 volts. Okay. And that is option C. The correct answer option is C. We'll take the next question. The next question says, in a series RLC circuit, at resonance, the dash A, capacitive reactance equals the inductive reactance. B, resistance is 0. C, voltage is maximum across the inductor. Now D, current is minimum. Please, this type of question, you don't need to waste your time. At resonance in RLC circuit, at resonance, we now have that XL becomes XC. Simple. So at resonance, the reactance of the inductor is the reactance of the capacitor. Now we take the next question. That means the correct answer option there is option A. Simple. Now we take the next. This question on the board. If the stress on a wire is 10 raised to power 7 Newton per meter squared, and the wire is stretched from its original length of 10 cm to 10.05 centimeter, the Young's modulus of the wire is dash. And the Young's modulus must be any of these options there. Now, solution. We have that from here, stress is 10 raised to power 7 Newton per meter squared. Now, original length L0 is 10 centimeter. Now, extension, it was stretched from this. Now, extension, of course, we know how to. Extension is the extended length minus the original. The original length minus the extended length, or you can say final minus initial. This is the final here minus initial, which will give us 10.05 minus the original length, which will give us 0.05 centimeter. Remember, all these things are in cm. The Young's modulus is what you're looking for. Now, recall that Young's modulus is tensile stress all over tensile strain. Stress was given. Now, strain, how do we get this tensile strain? Tensile strain is equal to the original length all over the extension. Sorry, the strain is equal to extension all over the original length. Now, which will give us, at this point, because two of them are in cm, there's no need to convert them because it will still cancel out, the cm here will still cancel out cm here. So we now have the extension is 0.05 all over the length is 10. Now, which will now give us that the strain is 0.05 divided by 10. It will give us that strain, tensile strain is 0.005, no SI units. Now, having gotten the strain, we have the stress already, we'll move into this equation. So we now say that the Young's modulus is stress over strain. The stress is 10 raised to power 7 all over. Now this one, you can still convert this one to standard form, which will give us 5 times 10 raised to power. If you shift this, 1, 2, 3, minus 3. Now, if you do that, we have 5 times 10 raised to power minus 3. Remember, this is index numbers. And this thing is something as writing that this 10 raised to power 7 is something as writing 1 times 10 raised to power 7, so that I don't get confused. Which will now give us, I want to send this base up if I send it up, this minus 3 will turn to positive. So which would that give me? 1 times 10 raised to power 7. If you send this one, it becomes plus 3 all over this 5 here. Now 1 over 5, 1 divided by 5 will give us 0.2. 0.2 times 10 raised to power. Now 7 plus 3 will give us 10. Put this in a standard form. You shift this and this one will reduce by 1. 2 times 10 raised to power 9 Newton per meter squared. Option D is the correct answer option. Okay, now we have these questions here. The first question says, when the human eye loses its power of accommodation, the defect is known as dash. We have the first one, astigmatism. We have the second one, long-sightedness. We have the third one, presbyopia. And we have the fourth one, short-sightedness. Now, if you look at this, and of course, when the eye loses its power of accommodation, these two is not among the options there, because it cannot cause long-sightedness. It cannot cause short-sightedness. Now, these two is off. Now, we have between the astigmatism and the presbyopia. Now, the first one, maybe let us look at what is presbyopia. Now, this, astigmatism. Astigmatism, because we know that it is caused by the eye part, which is the cornea. When the cornea is not located, maybe when the cornea is either spherical or parallel, either spherical or plane. Now, in that case, it causes a distortion of vision. So when the vision is distorted, it has not lost its property, its power of accommodation. So in other words, when human eye loses its power of accommodation, it results to what we refer to as presbyopia. Now we have this next one. The next one says, which of the following is not affected by friction? The key word there is friction. So which of these is not affected by friction in machine? The first one, mechanical advantage. Second one, velocity ratio. Third one, effort. Fourth one, efficiency. And of course, we know the role friction play in a simple machine. So in a simple machine, mechanical advantage is highly dependent on friction. Of course, both the effort and the efficiency, all of them, before effort is applied on a particular part of the machine, there must be a contact there. So friction must be there. Now, the one that does not depend on friction is the velocity ratio. Velocity ratio does not depend on friction. Rather, velocity ratio is highly dependent on the working parts of a simple machine. So it does not depend on friction. These other ones are friction dependent. 1, 2, 3. They are friction dependent, while this one is highly dependent on the working part of the machine. Now we have this question on the board. This question says, during thunderstorm, lightning and thunder occurred simultaneously in the atmosphere. An observer on the Earth's surface sees lightning flash shortly before hearing the thunder. This is because, so what is the reason why you see the lightning first before hearing the sound? Now, option A, atmospheric pressure is higher at the surface than at the higher altitude. Altitude has to do with high. Does it mean that the atmospheric pressure is higher at the surface than at that high altitude? B, speed of sound is less than that of light. C, temperature of the atmosphere decreases with altitude. Does it mean that as you go higher, temperature reduces? D, atmospheric density decreases with altitude. Density of the atmosphere, does it decrease with altitude as you go higher? Now, if you look at this question, most times they might twist the grammar just to confuse you. Of course, we know that yes, light travel faster than sound. That is why we see light first before hearing sound. Now, in this case, B says speed of sound is less than that of light. Yes, the speed of sound is less than that of light. If you turn it the other way around, that means light has a greater speed than sound. That is why you see the light flash first before it will be accompanied by that sound. So in other words, B is the correct answer option. Question here: which of these is a natural satellite? Of course, we know we have two types of satellite, natural and artificial. So which of them here is a natural satellite? We have the sun, we have the rocket, we have the moon, and we have the Sputnik 1. From here now, these two are artificial. They are off. That is one of the ways to point out the correct option. So rockets, Sputnik 1, these are artificial satellites. Now what is remaining is the sun and the moon. And of course, the sun is not a satellite. A satellite is just an object that orbits another. The sun is just at one focus. It doesn't orbit. It is only the moon. Of course, the moon is a natural satellite that orbits the sun. Therefore, the correct answer option there is the moon. Now we have this. Which of the following is an advantage of a thermoelectric thermometer? You know the types of thermometers we have, and then each of them has its specific use, and then where they are used. Some of them are used in the laboratory, some of them are used in the hospitals, some of them are used in the industries. Now, and of course, thermoelectric thermometer or thermocouple is used in our industry. Why do we use it there? Do we use it? Is it because, one, it is not suitable for measurement of rapid changes in temperature? No. Two, it is sensitive. Yes. The correct answer there is that it is sensitive, very sensitive to any varying temperature changes, just like the gas thermometer. That one is very sensitive to any temperature change. It is fragile. Its fragile nature is not why we use it. It is not very accurate. It is not why we use it. So remember, the key word there says which of the following is an advantage. So the only advantage it has there is option B, which is very sensitive. Now, the next question says, a meter rule is pivoted at its midpoints. I will clean here so that we'll solve from here. Okay, so we have that a meter rule is pivoted at its midpoint with a vertical force of 10 Newton, hanging from a distance of 30 cm from the midpoint. At what distance must a 15 Newton force hang to balance the rule horizontally? A, B, C, D. Now, the first thing you do is to represent this so that you understand what you are doing. Now, a meter rule, once you hear meter rule, here is 0, here is 100. Now, let's say it is pivoted at the midpoint. The midpoint is 50. So, it is pivoted at its midpoint with a vertical force of 10 Newton hanging from a distance of 30 cm from the midpoint. That means from the midpoint, count 30. So if you count 30, from there to here is 50. If you 30 cm away will give us 20 here. That means 50 minus 30 will give us 20. So it is hanging at that 10 Newton force is hanging at 20 centimeter point. Therefore, the perpendicular distance is that 30 cm. That is the point they are driving here. Now they said, what distance must a 15 Newton force hang on the other side of the meter rule in order to keep it vertical? So assuming I have another mass here, 15 Newton. So the distance it will have here is x. And of course, we have that here is anti-clockwise, while this side is the clockwise. Now, from principle of moment, clockwise moment is equal to anti-clockwise moment. So clockwise moment is this times this, which is 15 times x is equal to the anti-clockwise, this times this, 10 times 30. 15x is equal to this times this, which is 300. Now x will give us 300 over 15 will give us 300 over 15 will give us 20 centimeter. The options here, we have option C. Option C is 20 centimeter. Now we take the last but not the least question. We have this question. The question says, the current through a resistor in an AC circuit is given as 2 sine omega t. Determine the DC equivalent of the current. Now, in this case, this is of course, you know that the alternating current is expressed as I equals I naught sine omega t. Now, in this case, whatever value you have, if you compare this with this equation, that means this is our peak current. That means I naught is 2 ampere. Now, but the DC equivalent, recall that DC equivalent is the IRMS. That is the DC equivalent. Therefore, we now have that IRMS is equal to I naught all over square root of 2. This is the formula. We are looking for this. In other words, I naught is this. Put it here. So if you put it here, we now have that I naught is 2. 2 all over square root of 2. Now this is such. Do we just leave it like this? How do we rationalize this? Multiply both sides by the value of the denominator. So if we multiply both sides by the value of the denominator, we now have 2 all over square root of 2 multiplied by root 2 all over square root of 2. And when you do that, you now have 2 times root 2 will give us 2 root 2 all over root 2 times root 2 is root 4, and then square root of 4 is 2. Now in this case, 2 can cancel 2, and if 2 cancels 2, we now have root 2 remaining. Therefore, IRMS is equal to square root of 2 ampere. So this is the correct answer option there. Please, there are so many questions. If we continue to bring all those questions and solve them, this video will be longer than this. There are other questions. Maybe we'll create another video for them to complete those ones. Please, if you have not subscribed to this channel, please do me this favor, hit the subscribe button, share this video with your friends so that they can have the same knowledge with you and then know how to prepare. Remember, day 1 is easier than day 2. Day 2 may be easier than day 3, or maybe tougher than day 3. I wouldn't know. So please read. The most important thing is you have been studying before now. Take your time, read your book, Anyone that you are not too convinced, there is a link down there in the description button. Please hit that link and then come to our WhatsApp group there, bring it up, and then we'll answer you there in the WhatsApp group. Or you can drop the question in the comment section. I will address those questions. Thank you for being with me. If you're not writing exam tomorrow, please by tomorrow I will bring day 3 questions so that we brainstorm. Thank you very much.